6.18 Flowchart. As I explained to you earlier, flowchart is a graphical representation, visual representation of algorithm. So, for each type of operation, certain symbols are provided. Actually, for starting and ending of the program, for defining a condition, for IO, for calculations and all that, different symbols are defined. By using those symbols, we write the flowcharts. Now, flowcharts can be classified into two groups. First one is program flowchart. Second one, system flowchart. Program flowchart describe or present the sequence of instructions in a program. The sequence of instructions for solving a problem is presented by a program flowchart, and system flowchart, flow of data throughout the data processing system. System flowcharts represent flow of data through a data processing system, flow into and out of the system. Actually, in data processing system, the flow of data and into the system, out of the system is represented by system flowcharts. So, understand program flowcharts and system flowcharts. Program flowcharts describe or represent the sequence of implementation of instructions to solve a problem. Understand? And system flowchart represents the flow of data in a data processing system, and it describes how data is flowing into the system, flowing out of the system also. Now, mainly, we are concerned with program flowcharts. In program flowchart, these symbols we use. This is the terminal. Terminal means that it represents the start and end of a program. Start and end of the program. This is the symbol, like a vowel. Next, a rectangle. Rectangle always represents a process. Process includes calculations or any processing or any function. Next, this is IO. Input and output should be represented by the symbol. Next, condition. Any condition. Actually, condition means it may be a comparison. It may a question or a decision are represented by the diamond symbol. And next, annotation. Annotation is that symbol. It is descriptive comments, clarification about the program. If you want to give any descriptive clarifications, you can use annotation. Connector. From module to module, if you have to connect, then this connector entry from and exit to. Entry from and exit to are defined by represented by these symbols. Next, predefined process. And some process is defined elsewhere. Some process or function is defined, not part of the program. And if you have to describe about that, you can use this symbol. Use this symbol. In this way, all these symbols we use in flowcharts. So, once you, for every algorithm, you try to write flowcharts by practice, just a simple practice. You can learn this, and if you are able to write flowcharts for the algorithm, then it is more readable. The reader can easily understand the steps in the algorithm using flowcharts. Now, let us write a simple flowchart. Already we considered one case, that is evaluating the volume of a cylinder. In that, this is the algorithm. Start program, input radius and height, computation, that is evaluating volume using a formula. Fourth step is outputting volume, and fifth step is stop program. Now, how to convert this algorithm into a flowchart? Already explained symbols. Now you see, this is starting program. After starting program, thereafter second step. This represents first step, and this represents last step. Fifth step, stop. Thereafter inputting radius and height. This is now the symbol for IOs. We are writing this symbol, and IO, inputting radius and height, outputting the volume. So the two steps we are writing. Thereafter, computation. For computations, we are writing a rectangle. Now calculate volume using formula. This we are writing. Now this is the pictorial representation. Just every time you practice, in many cases, I have given an algorithm and you study and practice, then you can better present the strategy of a program through flowcharts. And in the same context, I would like to give you an example to compare algorithm and pseudocode also. Page number 378. Please refer to this. Here, a simple case I am taking. X, Y numbers. We are comparing X and Y numbers, and find the smaller in X, Y. So I have written both algorithm and pseudocode. Just side by side I have given. You compare both, understand the difference between algorithm and pseudocode. Actually, otherwise, with reference to an example only, you can find the difference between algorithm and pseudocode. Otherwise, it is not possible, what I feel. Now you see, algorithm. Get numbers X and Y. In algorithm, every step we write generally. Suppose if you have to describe to your friend, how you describe, the same manner. Now we see the algorithm, get numbers X and Y, compare X and Y. If X is smaller, smaller is X. If Y is smaller, small is Y. Smaller number is small. That is the way you write in a general language. And in pseudocode, almost similar, but you use language-oriented words. Those are relevant to language. Now you see input X, Y. If X is less than Y, you are using language-oriented symbols also. If X is less than Y. If yes, X is smaller than Y. If no, Y is smaller than X. Print the smaller number. In this way, pseudocode, whatever you write and all that, it is you use many terms belong to language, and language-oriented symbols also used. That is the difference. Algorithm is a general description of a logical sequence of steps, and pseudocode is also a description which is relevant to the programming language. Okay, that is the difference. And by this, you understand what are the flowcharts, algorithm, and pseudocode, and you learn the symbol. Flowchart just like that you cannot draw. You get a lot of doubts. So I have given many examples in this book, and every time whenever you develop an algorithm, try to transform the algorithm into flowchart. It is always a good habit. Gradually, you can get expertise over this thing, and for every program, you first develop an algorithm. Thereafter, you can transform the algorithm into